before. Okay, now it's quite confusing, but let's go over it. Back titrations. I'm going to start with an analogy. Yes, it was horrid. Okay, I'm going to start with an analogy. Now, let's say that you've made a delicious cake, right? You've made a massive cake. You put it in the fridge. You wake up the next morning and you discover that someone has taken a slice out of it. You don't know who, and you don't know how much has been really taken out. Now, tell me, guys, for all you keen bakers or anyone, how could you work out how much of that cake is missing if you knew the mass before? What could you do? Yeah, old minus new. So you could do like the difference in mass, exactly. So you know the moles at the start, moles. Yeah, so moles is like the cake. If you look at the moles at the end, you know how much has reacted. And that's what we're doing in back titrations, okay? So think of that cake analogy. Now, for example, here's a typical question. Imagine that we're trying to find out how many moles of calcium carbonate we have. We add 10 moles of hydrochloric acid, which is in excess. The excess is made up to 250 stock solution, and then we titrate 25 of it, and it requires that amount of sodium hydroxide. Now, when you're in exam, if you're anything like me, you read that and you just think, what? So you have to read it again and again. But let's spot two things. Number one, they say excess. Number two, there are going to be two separate reactions here. So let's just draw out exactly what's going on. So we have this volumetric flask, right? We've got a volumetric flask. And in there, we've got our hydrochloric acid, which is in excess. We've also got our calcium carbonate. Now, it's our calcium carbonate which we're trying to work out, okay? So here's an equation. Calcium carbonate plus hydrochloric acid will go to calcium chloride plus water plus what else, guys? It's a carbonate. What else do we produce? Carbon dioxide, thank you very much. Carbon dioxide, a little bit of balancing, so I whack a big 2 in front of there. So straight away, this is my unknown, okay? That's what they're asking us to work out in the end, okay? This is in excess. So I've got a hint that it's a back titration. Then what we're doing is we're taking out a section of that, and then we're doing a titration. So here's me drawing the burette into our conical flask, and in our burette, we've got our sodium hydroxide, and in here, the hydrochloric acid. This is the hydrochloric acid left over. So this is the cake that's had a bite taken out of it. So I'm going to put left over here, okay? So that is unknown. Now we've got a second equation. So we've got sodium hydroxide plus hydrochloric acid goes to sodium chloride plus water, okay? So 1-to-1 molar ratio. So now we think, okay, CMRR is going to come to our rescue. Circle, moles, ratio, rearrange. Now we always start, as in with all calculations, we start with the titration data, okay? Even if you're totally confused, you can always get a mark by working out the moles. So we've circled our unknown, our big unknown, but let's start off with this equation. Our unknown is this stuff, which is left over, okay? So we calculate the moles of the sodium hydroxide, okay? And it's told us in this question 0.4, okay? So we know the moles, that's 0.4. The ratio is 1-to-1. So far, excess is a keyword. And when we see two equations, we know, oh, this is back titrations. Okay, so we do the ratio. We've just done that. But then we've got to scale up. We need to go back into the original. So it's CMRR with a scaling, which we've seen before. So guys, just remind me, if I've taken 25 centimeters out, how do I scale the moles up to 250? What do I have to do to my number? Times it by 10. Yeah, times it by 10. So we scale up, we times it by 10, and now we have the moles of our hydrochloric acid. So going back to circle moles ratio scale up, we haven't yet gone to the rearrange thing. We go back on ourselves. That's why I think they're called back titrations, okay? We go back on ourselves, right? We go back. So now we work out the moles left over. We do the moles at the start minus the moles that's we've now got equals the moles that's reacted. Think of the cake, okay? We measured the mass at the start, then the mass at the end, and we got the stuff that reacted. That's what we're doing now. We just did a titration on the hydrochloric acid, which is left over. So then we do a minusing. Does that make sense? So we go back and we do a minusing. We do moles at the start, which they've given to us, which was 10, minus the moles at the end, moles at the end. So scaling up from 0.4, we have 4 moles in total. Because it was 0.4, we scaled it up. So we do 10 minus 4. We've now got 6 moles. Now, guys, is this making rough sense so far, what we're doing? Circle moles ratio, then we went back because we scaled up, and now we're into the other equation. Give me a thumbs up if this is kind of making sense. And again, don't worry if this isn't. If you watch it back and then do a question, it will start to make sense, trust me. Okay, and now finally, we do a ratio. Okay, we do a ratio. We're going back to ratio. We divide by 2. And then I've got the moles of calcium carbonate. That's a back titration. Circle, moles, ratio. Then you go back into yourself and you do it again. And there's going to be 2 equations. Think of the cake. Start at the end. Yes, well done, Emily. That's the correct answer. Okay, that's back titrations. They're quite scary, aren't they? Now, guys, here is another question. And I want you to tell me, guys, how can you tell that this exam question, this will be worth 5 marks? How can you tell that this is a back titration? What are the 2 bits of information that give this away? Two equations. Well done, Louisa. 2 equations, definitely. And also the word excess. The word excess. So we're learning to spot these key things. 2 equations, think of the cake. Think back titration. Excess, think, right, in the end, we're going to do how much is reacted by a subtraction. And then we've seen a 250 down to 200, down to 25. We've got a scaling up. Circle, moles, ratio, rearrange. We've got a scaling up. And then because it's a back titration, we go back here into the other equation. So this is our big unknown. Okay, this is a typical back titration question. Now, in true baking form, here's one that I made earlier. So I did this a bit before, and let's just follow what's happened. So calculate A, the moles, and B, the mass of magnesium carbonate at the start if this amount, this number of moles of sulfuric is added to the magnesium carbonate and an excess sulfuric acid is made up to 250 solution. 25 of this requires this amount of moles of sodium hydroxide solution. Okay, so there's our moles of that. We start with the titration data, circle, moles, ratio, rearrange. So over here, I've done the circle, I've done the moles, that's been given to us. I then look at the ratio, so that's why I have divided it by 2, and this is our leftover sulfuric acid, okay? We then have a scaling up. So I'm going from the conical flask into the volumetric flask, I'm timesing by 10. This is my leftover sulfuric acid in the big volumetric flask. But I then go back on myself, I do another moles and another ratio because I'm now into this equation, right? So this is me doing the subtraction. We got the moles at the start minus the moles left over. They told you this in the question over here. And this is the amount of sulfuric acid that reacted. And then we finally do our rearrange stage, okay? We've now got the moles of magnesium carbonate, so 1-to-1 molar ratio. We rearrange, moles equals mass over MR, and we're done, okay? Excess, yes, indeed. That's back titrations. So if you're following that, very well done. If not, please do watch the lesson back. So we're going to move on now. That's back.